All right, today we're going to be discussing a new topic called simplifying radicals. So we'll be looking at simplifying square roots today. So just accessing some prior knowledge, prime factoring means to factor a number until it's broken down to a product of only prime numbers. So basically to keep breaking down the number until we can write it as a product of just primes. So I start by making a factor tree. And I noticed that 2 goes into 24, so 2 times 12. And then 12 can be broken down into 2 and 6, and then 2 and 3. So now that I've broken down every factor into just prime numbers, I can rewrite 24 as 2 times 2 times 2 times 3. So if I did this correctly, this should multiply out to 24. So let's factor 27. So I know that that multiplies to 3 and 9, and then 9 can break down once more into 3 times 3. So 27 can be rewritten as 3 times 3 times 3. I tend to be in the habit of starting by seeing if I can get any 2s out of my number. If I can, I take those out until I can't take any more 2s, and then I look for 3s. So, you'll kind of in a pattern or in a habit when you do this. So for square roots, the technical definition is if x squared equals y, then we say x is a square root of y. So if you were to look up square roots in a math textbook, this is what you would see. In the expression, the square root of 64, the square root is the radical, and 64 is the radicand. So the number underneath is the radicand. And we'll just be using that vocabulary throughout, so you want to be familiar with that. So it says find the root of the following. You might realize 4 is a perfect square. So what would the square root of 4 be? It's 2. You should know that. I've got a negative on the outside here, so I'm going to bring that along. And the square root of 25 is 5. And the square root of 121 is 11. So those are ones that we should just know. We could go backwards. 11 squared would give me 121. 5 squared would give me 25, and 2 squared would give me 4. Now here's the unfortunate part, is not all numbers have a perfect square root, as in the previous examples. So if a number is not a perfect square, then you might be able to simplify it. So you can't get just a number like that, 5, 11, or 2, but we can at least simplify it. So here are the steps to do that. First, we're going to prime factor the number, look for pairs, take one representative out of each pair, and then simplify. So I'm going to take you through that process right now. So I look and I notice 8 is not a perfect square. So I'm going to start factoring that. I'm going to start a factor tree. So 2 times 4 multiplies to 8, and then I can break down 4 into 2 times 2. And every time I have a prime number, I circle it so I remember to bring that back up. Basically, what I'm going to do here is I'm going to gather up all my prime numbers. So all these numbers that I circled, 3 2s, and I'm going to put them back under the radical. So I'm basically just rewriting 8 as 2 times 2 times 2. 2 times 2 times 8. So that's 1. So factor and rewrite your number as just a product of primes. Then step 2 is to circle any pairs. So I've got a pair of 2s. For every pair, you take one representative out from underneath the radical. So because I had a pair of 2s, I'm going to take those out and put one representative on the outside. Any number that doesn't have a pair is left under the radical. So what is the square root of 8? Our final answer is it simplifies to be 2 square root of 2. And why is that? Well, think about this. What is 2 times 2? It's 4, right? Well, what's the square root of 4? 2. So that's why when I have pairs, I take one out because I'm square rooting the pair to get it down to just 1. So let's try some more examples. I'm just going to factor 20. So that's 2 times 10, and then 10 is 2 times 5, and I'm going to circle any number in my factor tree that were prime. Now I'm going to gather those up, put them underneath the radical, so I'm basically rewriting 20 as 2 times 2 times 5. 2 times 2 times 5. Now I'm going to look for any pairs. I've got a pair of 2s. So those come out from underneath the radical as one representative, and any number without a pair stays underneath. And why is that? Because 2 times 2 is 4. So what's the square root of 4? It's just 2. That's why pairs come out. But you don't write it twice. Like I only have 1, 2, because when I square root both of the 2's, I only have 1 left. Square root of 4 is 2. All right, let's factor 72. So I always start with 2 and 36. If 2 can go in, then I start by taking that out. 36, I don't know, it could be 6 times 6. And then 6 break down into 2 times 3. So I'm going to gather up all my primes since they can't be broken down any further. And I'm going to put those under the radical. So I have, let's put all our numbers that are the same together. So like 2 times 2 times 2, I have 3 2's and I have 2 3's. Makes it easier to look for pairs. So I've got a pair of 2's and I've got a pair of 3's. I'm going to take out 1 representative for that pair. I'm going to take out 1 representative for this pair. And left underneath the radical is a 2 because it didn't have a pair. And then if you take out more than one number, then you're just going to multiply those together. So that's 6 square root of 2. And if I have more than one number left underneath, say like a 2 and a 5, I just multiply them together. So these are your you-do problems. I would pause if you're watching this at home and try those, and they will be something we do in class. So I'm not going to give the answers here. All right, so that's how to simplify radicals when they're just numbers. Let's look at what happens when we have variables as well. So it's pretty similar. It's a pretty similar process with one added layer. So step 1 is to factor numbers and variables under the radical by factoring the number into its prime factors. That's what we just did, and expanding the variables. So I'm going to prime factor the number. 8 is going to be 2 times 4. And then 4 breaks down into 2 times 2. So I'm going to gather those up. I've got 3 2's under the radical. And I'm going to expand my variables. So I've got 4 x's and I've got 2 y's. So that's step 1. Factor the number, expand the variables. Step 2 is to circle any pairs. 1 representative comes out from under the radical, any numbers left are left to stay under. So I've got a pair of 2's, so I'm going to take out 1, 2. I've got a pair of x's, so I'm going to take out 1x. I have another pair of x's, so I'm going to take out another x. And I've got a pair of y's, so I'm going to take out a y. So every pair gets 1 representative out front. And then let's look, were there any left underneath that didn't have a pair? Yep, just 2. And then step 3 is just to simplify. So I'm going to condense down anything that I need to. So like x times x, is x squared. If there was more than one number, I'd multiply them together at this step. So I end up with 2x squared y times the square root of 2. All right. And then here's a little TEI question. These are the type of questions you might see on the SOL where you have to like select more than one answer, and they are weighted more, so they are worth more than a multiple choice question. They are more work, but they're also weighted more points. So it's good to do them. Put that extra effort in. So circle each expression that is completely simplified. So by completely simplified, what they mean is if I were to expand, and all I'm looking at is the radicands, what's under the radical. If I were to expand what's under the radical, could I take pairs out? Are there any pairs left underneath the radical? So let's look at this, 12. If I were to factor 12, that would be 3 and 4, and then 4 is 2 and 2. So I notice underneath that radicand, inside of 12, I've got a pair. So that should have come out. This is not completely simplified. There was still a pair underneath that needed to come out. If I look at this, 2x, y, z, there's 1 of each. I can't factor anything else down. Again, there's no more pairs left underneath the radical. So that's completely simplified. Here, notice if I were to expand the x squared is 2x's, I've got a pair that should have come out. So this is not completely simplified. And if I look at 7x, y, z, that is completely simplified because they're all to the first power and 7 can't be broken down anymore. So as far as the variables go, I'm just making sure that none of the powers are greater than 1, because if they're greater than 1, I had a pair I should have taken out. So it's just these two that are completely simplified. You've got a couple UDO problems to try, so go ahead and do that. And yeah, thanks for watching.